Hi, I'm Matt Needham, and this is my lecture on troubleshooting electric motors. The thrust of this is really going to be dealing with fan motors, but a lot of the same principles apply even to hermetic compressors and pumps. So let's get started. So in troubleshooting a motor, you kind of want to determine whether it's a mechanical problem or an electrical problem. You don't want to be Neanderthal and just say motor bad. Well, what's wrong with the motor? Me say motor bad. It don't be like that. You want to be able to say, well, the motor's seized, or the motor's broken, or the motor is shorted, or the motor is grounded, or the winding is burned open, and then you instill a lot more confidence than otherwise. So you want to be able to distinguish that. And again, if a motor is seized up or bad, it's not going to be turning right. It may be making vibration, or it could be seized, which is not so difficult to ascertain if it's a fan motor, because you'll have trouble turning the fan or the pulley. In some cases, though, you may have to actually take, if it's a fan motor with a belt, cut the belt off or take the belt off to find out which pulley is struggling to move. Sometimes over-tightened belts can actually cause these problems of bearings going bad, shafts being worn out, etc. So we want to get the right belt tension in order not to have these mechanical problems. Now, if a motor is seized and it's not turning, but electrically it checks out okay, that means it's going to be drawing locked rotor amps and then maybe be tripping on an overload or something like that, and it won't be able to turn. The rotor is actually locked into place. It's not moving, and that's why you draw that high inrush current, and then it might trip off an overload or blow a fuse or something like that. Now, if we do have bad bearings, I know it says here not often repaired by field technicians. That's really not true. Maybe on the inside of the motor itself we won't be doing that, but if there is bearings like for pulleys and fans, it's quite often the air conditioning or refrigeration technician will be changing those bearings, and I've suffered many a long day doing that work. Okay. Now, a lot of times it's difficult if you're working on changing a bearing, a pulley, a coupling, something like that. I've had some that just come right off easily, and then others it's like, come on! No exaggeration, and you literally gouge the metal out of the shaft. But I'll give you some tips on dealing with that. First of all, if you're going to change bearings or a pulley or anything, the first thing I think you should do is to remove any set screws, and then take some kind of break-free, or they have this newer WD-40 that has an extra loosening action, and spray it in the holes and wherever you can, and then just put the set screws back in finger tight while you go off and get new bearings and sandpaper and drop lights and tools and all kinds of things and pullers. Okay? You also want to clean your shaft and everything as good as possible. If there's some big gouges in it, start with a file and then use sandcloth to smooth it out, finishing in the direction of travel that you would like to take the bearing or the pulley off in. Be careful about hitting it with a hammer, even a soft mallet hammer, a shaft of any kind. They're saying, well, use a soft face hammer so you won't mushroom at the end of the shaft out like you would if you used a metal hammer. But you know, a lot of times if you're working on a fan that has bad bearings, and on one end of the shaft you have the bearing, and then on the other end you have another bearing, and in between you have a long shaft and a fan, you might be working over here and focused on this and be banging back and forth trying to get this bearing loose. Meanwhile, you're putting enormous pressures on the other bearing, and which was okay before you started. Then you finally finish the job and put the new bearing on over here, and then when you start up the motor, you get now that other bearing is causing you a problem. So be careful about putting too much force on your shaft, because you may be damaging the other bearing. Okay. We're going to show a picture here in a minute of a pulley puller, and you know, sometimes using a little bit of consistent vibration on a pulley or on a bearing or a coupling from different angles, even the soft end of a screwdriver, and just hit it 100 times. Just relax work. hitting at different angles. That vibration's great for loosening things up. So remember that. Also, if you're using, what we have next is a puller, where you put this puller on the shaft and then you screw in this with a wrench that should hold the shaft still and then pull the pulley off. And this is a cutaway version. It will come. I've actually broken a puller because this will be so almost like welded on there. It's insane sometimes. So if you get to that tension where you think something's going to break or give, just maybe give it a couple little love taps, and then go on break, go to lunch, do something else, and then maybe over time with that constant tension, or if you can leave over the night, you'll actually find that it pulls past that little piece of grit or something that obstructs this, and then when you come back, it will come off smoother. Not always, but I'm just giving you some tips. You have to be careful because there's oil and grease around here, but heating this a little bit, cooling the inside of the shaft, vibration, these are your friends. Now, belt tension, we kind of like to have a 1/2 inch deflection per foot. So from center of shaft to center of shaft, like this is about 1 foot, you'd want to push down about a 1/2 inch in the center of that per foot. And the longer the distance, if it's 2 feet, you'd want to be able to push down the belt in the middle about 1 inch. And they have belt tensioning gauges that can also be used. Okay? And then your pulley alignment. Your pulleys want to be aligned really straight. And a lot of times if you're trying to align pulleys with belts, a lot of times it's nice, especially if it's a bigger job, having someone to help you to get it aligned straight and torqued down. I'll give you a couple tips. Now, here they're showing you to make sure it's aligned here on 1, 2, 3, 4 sides, okay? So that a straight edge, that your belt would be lined up too. Sometimes you can actually just put your belt on there and kind of eyeball it straight, but this is probably a better way to do it. All right, so here's the motor and here's the fan. And the fan is always going to have the bigger pulley because it's going to run at a lower RPM than the actual fan motor. Okay, now electrical problems. We talked about mechanical problems where you might have, again, a bad bearing, something, a mechanical break inside the motor, something like that, a worn out pulley that may be on there that has to be replaced. But now we're talking about some electrical problems. Okay, let's dive right in. An open winding. Your motors have windings, single phase, a run winding, and a start winding. Single phase, 3 windings of equal resistance. And you want to get those measurable resistances with your ohm meter when you check it. And if you get an open reading, like if we're ohming this motor out and I reading across these terminals and I'm reading an open lead or an infinite, the same thing you would read when you have this set for ohms that you read right now measuring the air. That means you don't have a path for the electricity to get across the windings and the motor is bad. Be careful about condemning any really hot motor that may have an overload that is open. Give it a chance to cool down before you sentence it to eternal damnation. Okay. Shorted winding means you have an abnormally low resistance on that winding. Okay. And it's usually like very low, like 0, half an ohm, something like that, where the insulation on the winding has deteriorated and the wire is touching itself. Remember, in these motors, the wire has a lacquer coating on it that prevents actual electron flow between the wires, because that lacquer is like a insulator, okay? But we still get that nice magnetic field to move the magnets around, which, again, what a motor is just a bunch of magnets pushing other magnets around. So let's look at an example of that. And normally it's not quite like this, where, let me try and get there we go. That's a little better, sorry about that. Where the here you have the run winding, and the run winding is always going to have less resistance. So they're showing you a resistance of 2 ohms here, and then the start winding needs to have a higher resistance. Here it's showing you the same of 2, right? Meaning that it's shorted, which it should be a higher reading. Now that's not a great example. Also, if this is a fan motor, this is a giant fan motor, and normally they wouldn't have, it's more like a compressor, this low of an ohm reading. But normally this might be a half an ohm or 1 ohm. This might be something higher than what it's showing. But anytime you have an abnormally low reading, this is more likely under 1. When it goes bad, it usually goes bad. Okay. Now, short circuit to ground or frame. What does that mean? So here we have a motor. And let's say you're taking the resistance between a winding and the frame, and you want to stay off the paint and go to a good piece of metal, and you want to, like, you know, jam one of your probes in there, and then touch the casing here, like on this nice screw right there, and you want to read open lead or infinite from each one of the terminals to here, because you don't want electricity to come into your terminal and then to electrify the case. You want it to be just like you're reading air right now. The electricity is not energizing the air here, and you don't want it to energize the case. You want the windings not to be touching the inside of the metal, which is a ground, okay? And again, this goes back to ground, the casing of the motor, for safety. So that's what we mean by that, all right? Now, sometimes, like in compressors and things like that, air conditioning, refrigeration compressors, we might have a situation where you get 1,000,000 ohms from a terminal to ground. The motor's probably going to run and work under those circumstances, but it may mean that the winding insulation is deteriorated. You may have some dirt, some old oil, a little bit of moisture in your system. You may need to change a liquid line filter dryer, and if it's a larger compressor, change the oil. And it may let you know that this compressor motor is not long for this world. Okay, so they used to use Meggers a lot because Meggers would be able to read 10, 20, 50 million ohms to check the insulation quality of the windings. Some of these better meters, though, go up to 20 million ohms and can give you a pretty good idea what's going on. Okay. All right. You want to make sure that the problem isn't a bad relay or a bad capacitor or something like that, that it's actually the motor that is the problem. All right. Now on capacitors, we have 2 types of capacitors. A run capacitor, which is silver, and it's bigger and has a lower microfarad reading. And we have capacitor checkers now, which should be used instead of just the old style of using an ohm meter, where you can set it to microfarads here, and then some of the meters actually have a symbol of the electrical symbol for a capacitor that you put that on, and then you can hold the probes on your capacitor. Now, it kind of does use this ohm meter function, and the capacitor takes and gives a charge. So you've got to give this like good 10 seconds to give you a reading when you check a capacitor. Don't just put it on there and go, oh, it's dead. You've got to give it like 10, 15 seconds to be able to give you a reading. Also, the capacitor should be flat, like that on the inside. If you see any swelling, it's bad, all right? And it should read right near where the rating is on the run capacitor. And then the start capacitor, the same thing. But it has a little vent pop. It has that little circle in the center. And if that little circle is swollen up, replace the capacitor. Because if it's not bad, it's about to go bad. Okay? So you can use actually now the microfarad checker instead of just using the old ohm meter style, which isn't done anymore. Okay? Now, this is also a little outdated. Run capacitors actually go up to, I've seen 90 microfarads on single-phase 5-ton air conditioning compressors. 90, okay? And then start capacitors, actually I've seen up to 400 microfarads. And they're more common in like refrigeration compressors, because when the system's off, the evaporator's very cold and the pressure's very low, and when it goes to restart, it has to overcome a greater pressure difference and it needs more help in doing so, thus the start capacitor. Okay? Now, you want to make sure that you have proper voltage and that you're not over-amping your motors. You want to look at the full load amps and make sure it's not exceeding that. You also want to just look for loose connections, rusted terminals, corroded terminals when you're working with these motors. Okay. Now it talks here about troubleshooting hermetic motors. These are air conditioning, refrigeration compressors. It says can be checked from the outside to the compressor shell. I want to caution you on that. Just like this motor is gold, compressors are kind of like the Rolling Stones. They're painted black. And that black paint actually insulates. So if you scratch that off a little bit with a file or some time and some sandpaper, you'll get a good ground. But why do that when you have a beautiful thick copper suction line and a discharge line going right through the body of your compressor? And what's better than a copper conductor except a silver one? And so using that as your reference point for ground is a great place to go from each terminal to your copper pipe, which actually goes right through the center of your compressor and is attached to all that steel, is a great source for the ground. So you don't have to stop and file down the casing and get rid of some of that black paint in order to check your compressor. Okay? Now, here's the summary. And that concludes my lecture on troubleshooting motors.